So in my last video, I showed how to change from mixed numbers into improper fractions and from improper fractions into mixed numbers. Both a mixed number and an improper fraction can show you how many pieces there are and how many wholes you have with just a little bit of pieces left. So we talked about how to switch back and forth. Now we need to know, how does that go with adding and subtracting? So for addition, sometimes we will be adding fractions, and we'll just do something very simple like 1/4 plus 1/3. And after we've made it have common denominators, so times 3/3 times 4/4, it will turn into 3/12 plus 4/12. We can't add until the denominators are common because the pieces are different sizes. I only have one piece that's this big. I've only got one piece that's this big. By making our common denominators, I know that compared to each other, it's like having 3 pieces and having 4 pieces, so it's the same as having 7 pieces altogether. That's our basic form of addition. However, what would we do if we had maybe 3/4 instead of 1/4, and we had 2/3 instead of 1/3, and then maybe we have something else thrown into the mix, like a 1/2 and a 5/6. What if we have to add up a bunch of stuff? We still need to get a common denominator. For these numbers, all of them have 12 as a multiple, so I can turn all of these into 12s. For this one, I'll need to multiply by 3/3. For this one, I'll multiply by 4/4, because 3 in the denominator times 4 in the denominator will be 12. 4 in the denominator times 3 in the denominator will be 12. For this one, I'll do times 6/6, so that 6 times 2 is 12. And for this one, I'll do times 2/2, because 2 times 6 will be 12. The new version of my math problem will be 3 times 3 is 9/12, plus 2 times 4 is 8/12, plus 1 times 6 is 6/12, plus 5 times 2 is 10/12. The 12ths, adding these together does not change how many pieces would make a whole, so I'll still have 12 for my denominator. But once I start adding things up, 9 plus 8 is 17, 17 plus 6 is 23, 23 plus 10 is 33. I have way more pieces than I need to make a whole. My answer was an improper fraction. To simplify this, I want to change it into a mixed number. And how do I do that? Looking back up here, when I had an improper fraction, I just thought of the numerator as my dividend and my denominator as a divisor, and I divided them. I took my quotient to be my wholes, I took my remainder to be my numerator, and my denominator just stayed my denominator. So I'm going to do the same thing over here. I'm going to think of this as 33 divided by 12. 12 will fit into there 2 times. That'll use up 24 pieces, and that'll that'll leave us 9 pieces left over out of 12. Now, hopefully the students also notice, hey, 9 and 12 can both divide by 3, so I'll finish with 3/4. And then somebody will come along and tell them, hey, that's wrong. This was a mixed number. Your answer should also be a mixed number. Remember that whole. Another option is to simplify way up here. We had 33/12. I can simplify it right there and turn it into 11/4. Then I can say 4 fits into 11 2 times, and since that's going to be 8 pieces, I'll have 3 pieces left over, and I'll get straight to the 3/4 by simplifying up here. Either way, I'll still get 2 3/4. If doing this division mentally is difficult, I strongly encourage kids, even though it's relatively simple, to do the long division. find out that it goes in 2 times, find out that it uses up 8 pieces, find out that you've got a remainder 3, and then plug those numbers into their mixed number. When we add, we sometimes end up with improper fractions. Those improper fractions need to be simplified and turned into simplified mixed numbers. So that's what they're going to see with the addition. The subtracting can also be a little bit difficult. For instance, what if we had 4 wholes and I was taking away, let's say, 5/6, and I was also taking away 3/4. I'm going to do another version of that where I'm taking away 1/6 and 1/4. First, we might notice 6 and 4 are different from each other. We need to make those have common denominators. So after I use a factor to change them into having common denominators, 1 times 2 gives me that 2/12. 1 times 3 gives me that 3/12, because both of them have the number in the denominator to change into 12. I also need to borrow. When I have something like 40 minus 12, we can't do the 0 minus 2, so we'll borrow from that 4. It'll turn into a 3. This will turn into 10, so I can do 10 minus 2, 3 minus 1. We have a similar issue going on here. We've got 4 wholes, but we've got no fraction to take these pieces away from. So we're going to borrow just like we did here. When we borrow, that whole goes down by 1 and turns into 3 wholes. The one that we borrowed will regroup. In this case, it won't turn into 10 like it did with second grade subtraction. We have to look at our denominator and find out, oh, that's going to turn into 12/12. Once I've got my 3 wholes and my 12/12, now I can finish the problem. The 3 wholes isn't getting reduced over here, but the 12/12 is going down by 2 to 10, and then going down by 3 to 7. And our final answer is 3 7/12. Sometimes regrouping is slightly more complicated, because once I make my common denominator, I'm going to have a situation where I've got 10 pieces and 9 pieces, and regrouping one whole doesn't give me enough pieces to cover both of them. In that case, instead of just regrouping one, I can regroup more than one. I'll have 2 wholes, and instead of 12/12, I'll have 24/12. Again, I picked 12ths because my denominator was 12ths. In a math problem with eighths, I might pick 8/8 and have 16/8. If the math problem only had fifths, I might regroup 5/5 2 times and have 10/5. 2 minus no wholes will give me 2 wholes. Doesn't go down. 24 minus 10 is 14. 14 minus 9 is 5. So I'll have 5/9. Something else children could do is say, I'm going to take away 10 and I'm going to take away 9. That means I'm going to take away 19 in all and just do 24 minus 19, which will also get them to the 5. Either one of those solutions work. What is not on the homework, but what we have been going over in class, is what if we have a mixed number, not just a whole number, such as 4 and 1/5. And I want to take away from it something like 1 7/10. I still need to do the same procedure of getting the denominators to match. This will turn into, after I write down my factor of 2 halves, a 4 2/10. I don't need to change this one since it's already tenths. However, I still don't have enough pieces in the numerator to take away 7. So I'll regroup. I'll only chop up one of my wholes. Chopping up those wholes gives me 10/10 because my denominator is 10. Therefore, my 2 starting pieces plus my 10 new pieces will give me 12/10. This time I do have some holes to subtract. And then I'll do 12 minus 7 and get 5. And then the sharp-eyed student will notice, hey, 5/10 can simplify, so I'll divide and get 2 and 1/2, avoiding the mistake I made before of just writing down the fraction without bringing the whole part of the mixed number along as well. These two things are how we subtract on page 166. This is how we add and simplify our improper fraction into a mixed number on page 165. Hopefully that helps everybody get through tonight's homework. Have a great night.